So I'm going to show just how little astronomers know about the universe. And it's not even about the universe. I'm talking about our home galaxy, the Milky Way. So I'm just going to ask a very simple question that should have a simple answer. But as we're about to see, the answer is far from simple because astronomers don't know anything. Okay, so this is the question. How many stars are in the Milky Way galaxy? What is the answer? What do the experts say? Let's have a look. The Milky Way contains between 100 to 400 billion stars. Okay. Now we're going to go into details and how they came to these figures. But as you can see, it's not one figure. It's a range. Now that's okay. The Milky Way is huge and we'd expect a range of figures. We're not going to know the exact amount, at least not yet with current technology. But look at this range. 100 to 400 billion. There's a difference there of 300 billion stars. The low number is 4 times smaller than the high number here. Like it could be 100 billion, it could be 400. That's a huge difference. 300 billion stars of a difference. Now it'll be like you going to your grocery store. You get your groceries, put it in the shopping cart, go to the checkout. The checkout person scans all the items. And instead of telling you it's going to cost you this exact amount in dollars and cents, they're going to look at you and they're going to say, so it's going to be between $100 and $400. What? Yeah, that's what it's like. 100 and 400 billion. So what the hell is going on here? Apart from proving that this one question proves how little these astronomers know. At least 200 billion stars. And more recent estimates have given numbers around 400 billion. So this website, this organization, SEDS.org, they're saying it's a minimum of 200 billion. So 200 billion to 400 billion. So they've upped it from 100 billion to a minimum of 200 billion. On this page, they're the same. They're saying 200 billion to 400 billion. So these are the two sources here that I just looked at. So they should probably change this on Wikipedia because the two sources they use here both say 200 to 400 billion. So this article describes how they actually calculate the number of stars. So to make an estimate, we have to calculate the mass of our galaxy and then the percentage of that mass that is made up of stars. Okay, so this is how they do it. They try and calculate how much mass is in the galaxy and then divide that by a certain percentage to come up with the number of stars. Okay, so what is that percentage? We have to decide what mass of an average star is so we can calculate the number of stars in the galaxy. Okay, so let's come down here. This one goes back to the original estimate of 100 billion to 400 billion. This article here, space.com, this guy called Kornreich, this astronomer, says in a typical galaxy, if you measure its mass by looking at the rotation curve, about 90% of that is dark matter. Okay, so this is extremely important. So 90% of the mass is this mysterious dark matter. So it's like matter that you can't see. It's matter they don't know much about this. It's kind of a more theoretical phenomenon where there has to be more matter than they can see in order for the Milky Way to make sense in terms of how it rotates and how all the stars like stay together and don't wander off into outer space. So there's this thing called dark matter that holds it all together, and 90% of the Milky Way's mass is dark matter. So he goes on to say, with much of the remaining stuff in the galaxy made up of diffused gas and dust, Kornreich estimated that about 3% of the galaxy's mass would be made up of stars. But that could vary. Okay, so he's not talking about the Milky Way, but he's just talking in a typical galaxy. Now, is the Milky Way a typical galaxy? Who knows? But I would say he's probably talking about the Milky Way because obviously we know a lot more about the Milky Way than any other galaxy. If 3% of the Milky Way's mass is made up of stars, the rest is a combination of dark matter, which is the vast majority, 90%, and then like 7% would be gases and dust and other material that doesn't make up a star. This is where it gets kind of weird and confusing, and I think this is where the writer of this article, I think, makes a mistake, because they say, okay, so the Milky Way has a mass of about 100 billion solar masses in one calculation. Some astronomers made a calculation that there's 100 billion solar masses. So a solar mass is basically the mass of our sun. The mass of the Milky Way is about 100 billion times the mass of our sun. So it's easiest to translate that to 100 billion stars. So that would be if our sun is the average mass of all the stars. You take the average mass, and our sun just happens to be roughly the average mass. But here's the problem. Remember, up here, only 3% of the galaxy's mass is made up of stars. So if this calculation is correct, and it's 100 billion solar masses, and let's just say the sun happens to be the average mass of a star, then the number of stars in the Milky Way is only 3% of this. It's only 3 billion stars, not 100 billion. So this is a fundamental mistake here in this calculation, because remember, 90% is dark matter, and then like 7% is like all the gases and stuff, but only 3% is made up of stars. So 90 billion solar masses is dark matter, and only 3 billion solar masses is made up of stars. And if, let's just say, it happens that the sun is the average mass, this paragraph here doesn't take into account that only 3% of the galaxy's mass is made up of stars. It is easiest to translate it, well, it's not. It's only 3%. Later in the paragraph it says, however, the mass is tough to calculate. Other estimates have said the galaxy has a mass of between 400 billion and 700 billion solar masses. Let's just try and make sense of this. One calculation says 100 billion solar masses, and this one, it's anywhere from 400 billion to 700 billion. Again, a massive range here. This is crazy. Anywhere from 100 billion here to up to 700 billion. So this is saying there's like 7 times more mass in this calculation than this one. It's crazy. It's like going into a store, buying a can of Coca-Cola, and then the guy saying, well, it's either $1 or it's $7. Like, what's going on here? This is crazy. The next paragraph, the European Space Agency is mapping the stars. So this was June 2021. So this is recent. Now, the reason I'm talking about this is because there was a calculation done since this was written, I believe. In March 2019, astronomers reported that the mass of the Milky Way galaxy is 1.5 trillion solar masses. What? Let's go back to this one here, where it was saying it was 100 billion here. Then it was saying it could be up to 700 billion. But now it's saying it's 1.5 trillion, which is more than double the 700 billion. So 1.5 trillion is like 1,500 billion, which is just over double this number. So 1.5 trillion solar masses with a radius of 129,000 light years. So again, this one expands the size of the Milky Way by about 30,000 light years, because I remember seeing the figure of 100,000 light years quite a lot from numerous sources. This calculation in 2019 puts the Milky Way galaxy 30% wider. Well, actually, if it's a radius, it means that the diameter is double that. So it must be 260,000 light years, or 258,000 to be exact. 258,000 light years across, which is way more than 2.5 times wider than what I've previously learned, that it's 100,000 light years across. This is crazy. So over twice as much as was determined in earlier studies, and suggesting that about 90% of the mass of the galaxy is dark matter. So again, we have this 90% dark matter. Okay, so we need to calculate 10% of this, which would give us the 10% of regular matter. So that would be 150 billion. And if this guy is correct, saying that only 3% of the galaxy's mass will be made up of stars, that would mean 3% of 1.5 trillion is 45 billion, right? So I did this calculation earlier. So if this more recent calculation is correct, 45 billion solar masses is the mass of all the stars put together. So if our sun happens to be the average mass of a star in the galaxy, that would mean there's only 45 billion stars. It would actually only be less than half of this lowest number of 100 billion. But if the mass of the sun is way higher than the average mass of a star, then these figures could be correct. But if the sun's mass is way lower than the average, then there's going to be less than 45 billion stars in the Milky Way. So very hard to calculate. So I mean, I'm not saying astronomers are dumb or stupid. I'm just saying that this very simple question of how many stars are in the Milky Way, it's so hard to calculate. And interestingly, this is written in June 2021, and this one was 2 years previously. So I don't know what's going on here. This article seems to be like way out of date, or maybe the Wikipedia article is out of date. Who knows? It's a very simple question, and yet we have such a huge range of numbers. It could be as low as 45 billion. It could be less than 45 billion. Alright guys, so that's it for this video. Be sure to like, subscribe, comment, all that good stuff. See you guys later.